The Gestalt law of common fate, as it is usually understood, states that objects moving with the same velocity will be perceived as a group, as with these two elements. In this work, we hypothesize a broader interpretation of common fate, and investigate whether the law extends to other dynamic visual variables, such as dynamic luminance and dynamic size. Here is a summary of the visual variables that we used in our experiment on perceptual grouping, and how we manipulated them to make objects behave similarly or act in an opposing fashion. We did pairwise comparisons, making two variables compete with one another to determine which variable had the stronger grouping power. Here is our experimental interface, consisting of the viewport, where the participant sees the animated transition, and a list of 3 possible grouping choices for the 4 objects. The animated transition loops continuously until the participant validates their answer. The participant may choose A, B, and C, D if dynamic luminance influenced her perception of the groups, or A, D, and B, C if static size was a stronger visual cue for grouping. A third choice, consisting of the groupings A, C, and B, D, has no particular meaning in this trial. Let's look at another example. Here's a trial featuring dynamic position versus static size. The same velocities, represented by the green and red arrows respectively, may lead the participant to see the groupings A, C, and B, D, or the participant might instead perceive the groupings A, D, and B, C if common size has a stronger grouping power. If the participant chooses the groupings A, B, and C, D, it means they may not have perceived any relations based on the tested visual variables. In trials comparing two static variables, there will naturally be no animated transition, but rather a static image like this one, where static position is tested against static luminance. In addition to regular trials, we have hidden attention trials within our experiment, so as to detect insincere participants. Here is an example of such an attention trial, where only one grouping should make sense to the observer. In this case, both static position and dynamic luminance work together, meaning the only meaningful answer is to pick groupings A, C, and B, D. If the participant fails to pick the right choice, this can mean their response is careless, and their experimental data may be discarded if such errors occur too often. We conducted this experiment on the Amazon Mechanical Turk platform. 100 crowd workers participated in our experiment. We also conducted a follow-up experiment that consisted of questions about more realistic dynamic visualization scenarios, including a dynamic scatterplot visualization showing change in quality of life indicators for different countries, and a thematic map of election data in the United States. 10 participants took part in this experiment, which we ran in a laboratory environment. The participants were instructed to write answers to each question using the interface, but we also encouraged them to think aloud as they analyzed the visualization and answered the questions. The scatterplot visualization showed estimates of fertility rate, child mortality, life expectancy, and income, obtained from the Gapminder dataset. The animated transition shows linear interpolation between the values for all 4 indicators in 1960 and their values in 2014. Participants were shown a legend and axis labels for each question, which explained the mapping between these data variables and the dynamic visual variables. A side panel included a written reminder of the legend, as well as one of 3 types of question. The participants could replay the video as many times as desired to answer the question. The 3 types of questions asked participants to identify the patterns that they saw in the visualization by identifying several groups of points with similar behavior, find the country that was closest in behavior to a target country by pausing the animated transition and clicking on a candidate, and rank the dynamic visual variables and explain which ones they felt produced the most noticeable patterns in the visualization. Each question was repeated for 3 different scatterplots, which each had a different mapping of visual variables to data variables. The thematic map showed change in voter turnout and change in Democratic vote share for U.S. states between the 2012 and 2016 presidential elections. All points started out at the same size and color, and linear interpolation was used in an animated transition to a final state, which showed the magnitude and direction of the change in both variables between the 2 election years. Participants repeated each question for 4 views of the election map, which showed roughly 1/4 of the U.S. states. We asked the same questions for both the scatterplot and map examples. All experimental platforms are available online and can be accessed at these addresses.